All right, hello everyone. This video, I'm going to be going over a couple examples on problems involving direction fields of a first order differential equation, also known as slope fields. And I'll show you how to do, by hand a couple of these examples. But for the most part, I wanted to show you some websites, some computer aided stuff that will computer programs that will help you and make things a lot more clear than and a lot faster than doing these by hand. All right, so for both of these problems, I'm going to show you I have the following instructions. All right, first I'm asked to obtain a direction field or a slope field for the given first order. All right, I should say these are first order differential equations because only the first derivative is really talking about the slope of the tangent line to some curve, right? Some solution curve. Then sketch an approximate solution curve passing through the given point. All right, so here's our differential equation. All right, y prime equals x. Now, now, if you want to do this by hand, you can. Now, I'm not. I would prefer you do it on graph paper or something, but I'm going to do my best here with just making a rough sketch of the xy plane. And I'll label some points. Okay. So here's the point 0, 0. Here's the point 1, 0, 2, 0, 0, 1, 0, 2, 1, 1, 1, 2, 2, 1, 2, 2, negative 1, 0, negative 1, 1, negative 1, 2, negative 2, 0, negative 2, 1, negative 2, 2, 0, negative 1, 0, negative 2, 1, negative 1, 2, negative 1, 1, negative 2, 2, negative 2, negative 1, negative 1, negative 1, negative 2, negative 2, negative 1, and negative 2, negative 2. Okay, lots of points. Now, here's how you form a direction field or a slope field by hand. Now you could make now I made all my notches here just 1 unit apart. You could make these half a unit, a tenth of a unit if you want to get finer and finer slope fields. But like I said, I'm only going to do this by hand, probably just this once, maybe a second time, and show you how to produce these on your computer on certain websites and get the same thing visually a lot faster. All right, so basically this equation is saying that at any point the slope of the tangent line to the curve is just the x-coordinate. Right, slope of tangent is just the x-coordinate of that point. So for all these points here where the x-coordinate is 0, so 0, 2, 0, 1, 0, 0, 0, negative 1, 0, negative 2, the slope of the tangent line will be 0. So I'm going to put in these things called lineal elements, little bits of lines, little tiny bit of line, indicating to me that I've got a horizontal line here. So if any curve passes through, if any solution to this differential equation passes through that point, it's got to have a horizontal tangent line. And same thing for any of these points. So I'm putting little tiny horizontal segments, segments with a slope of 0 on these points, little lineal elements. All right, and then for these points, these all have an x-coordinate of 1. So the slope of a tangent line, if there's a solution that passes through any of these points, the slope of the tangent line to that curve's got to be 1. So I'm going to draw a little piece of a line segment with a slope of 1. So here's a little piece of a line segment with a slope of 1, rise 1, run 1 here. Little piece of a line segment with a slope of 1, slope of 1, slope of 1, slope of 1, right? Just little pieces of lines. So again, if any solution to this differential equation passes through these points, they've got to have the slope of the tangent line to that curve has got to be 1. All these points have an x-coordinate of 2, right? So the y prime would be 2. So I'm going to have little pieces of line segments with a slope of 2. So slope of 2, a little steeper, right? Slope of 2, slope of 2. Right? All these should be parallel. Slope of 2, slope of 2. And the same thing over here, right? All these points have slopes, have x-coordinates of -1, so y prime would be -1 at any of these points. So I put in little pieces of lines with a slope of -1. Right? Slope of -1, slope of -1, slope of -1, slope of -1. And then all these points, if a solution passes through any of these points, the slope of the tangent line would be -2. So here's slope of -2, slope of -2, slope of -2, slope of -2, and slope of -2. But you see how tedious this can be, right? And again, you can make it, instead of every 1 unit, you can go every half a unit, every 1/10 of a unit, make it even finer and finer. All right, so here's a direction field or a slope field, a very small one. I didn't do that many points, but I did enough. Here's a direction field for this differential equation. Now we're asked to draw a sketch, a quick hand sketch here of a solution, an approximate solution that goes through this point. The point, when x is 0, y is 0. So this point here. Here's the point. And you travel, you kind of think of these, these little lineal segments, these little lines I put up here, as pointing which direction a solution curve would have to go in. So remember, if I'm here at 0, 0, the little line here was horizontal. So I'm going left to right. And then, these are telling me I'm kind of curving up, right? Because, the point with x equals 1 should have a slope of 1. Then I'm going up, because again, I'm basically following. It's like a flow chart, like a little flow diagram. And same thing over here. If I move left of this point 0, 0, I'd have to go flat, and then start slowly getting bigger, bigger slopes, but bigger negative slopes, and moving up and up and up and something like that. All right. And again, that could continue on that way, continue on that way. And I'm seeing kind of a parabola shape. Here is an approximate solution to that differential equation going through 0, 0. All right, this pink or red line, the piece of graph I put up here. Just following the directions of all these tiny lines I put up in the direction field. All right, now there's a much better way of doing this, right? Again, you see how doing it by hand can be a bit tedious. Let me pull up some websites here. So all I did was type in slope field generator. Right, slope field generator. And a lot of stuff comes up. Now there's a slope field generator through Desmos. My favorite one of these that I've checked out is this slope field plotter through GeoGebra. So I click on this and up pops this slope field plotter. Give it time to load here. Okay, and then once it's loaded, now let me just, you see these solutions A, B, C, D, blah, blah, blah. I'm going to toggle that off so you see nothing right now. And you can make the, the density, you can control, it just tells you, basically makes it finer and finer. It gives you more, you increase the density, it'll give you more of those lineal elements, more slopes. The length you can control as well. Make the length of these little slope lines bigger or smaller. I'll make it a little bigger, make it a little denser. Right. And then up here you have f prime equals, right? or dy dx equals. And ours was just, y prime equals x. Right, here we go, look at this. Right. So here's all these slope elements when y prime equals the x coordinate. You can zoom in and out like usual. And then I'm going to pop on solution A, and I'm going to move this point to the point 0, 0. I'm going to double click on this point and just change it to the point 0, 0 that we had. And we'll see our solution curve that passes through the point 0, 0. And you see the parabola shape following these slopes. You see how it's horizontal, has a horizontal tangent at 0, 0 as it should. Yeah, so that's kind of what I had when I drew things by hand here. All right, but see, they put there's a lot more slopes there, and it can be a lot finer and a lot more accurate than your hand drawing. All right. Okay, so I've just got one more example here. Same thing, another first order differential equation. So we have a y times dy dx, or y times y prime, it's again first order, equals negative x. Now me personally, I would like to solve for y prime, alright, make it easier to calculate slopes and whatnot. So dy dx is equal to negative x over y. Alright, let's use that. And again, I can make a rough hand drawing here. I got the point 0.04 mentioned in the condition here, so I'm going to at least put that up. So here's 0, 0. Now notice that y can't be 0 here. So I'm going to use 0, 0. So here's 0, 1, 0, 2, 0, 3, and this is 0, 4, right? This is representing the point 0, 4 here. 0, 4, and then we'll do here's 1, 1, 1, 2, 1, 3, 1, 4, negative 1, 1, negative 1, 2, negative 1, 3, negative 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, negative 2, 1, negative 2, 2, negative 2, 3, negative 2, 4. All right. Now, just start looking at these points. All these points here where the x coordinate is 0. See the slope of the tangent line, y prime would be 0 over whatever y is. So you're going to have horizontal tangents again on all these points where the x coordinate is 0. So I'm putting little horizontal segments, right? Little horizontal lineal elements. Then for these points, point 1, 1, if x is 1 and y is 1, you have a slope of negative 1. So a slope of negative 1 here. 1, 2, you'd have a slope of negative 1/2. Alright, so a little flatter. So maybe like that. Here you'd have a slope of negative 1/3. So even flatter. Here you'd have a slope of negative 1/4. So even flatter still, but not totally flat. Here you'd have a slope of negative 2. Right, so negative 2. Then when x is 2 and y is 2, you'd have a y prime equals negative 1. So I think putting a little line segment with a slope of negative 1. Then here, negative 2/3. So, down to left 3. Or down to right 3. 1, 2, 3, 1, 2. So maybe about like this. Right, still a little flatter, and then here a slope of negative 1/2, so parallel to this one. Again, I'm just eyeballing here. All right, then over here you have a slope of positive 1 because you have negative 1 times negative 1 over 1. So a slope of positive 1 and positive 1/2, positive 1/3, a little flatter, positive 1/4, a little flatter. And here slope of positive 2 when x is negative 2 and y is 1. Slope of positive 2, positive 1, positive 2/3, a little flatter then, and positive half, so a little flatter still, and okay. All right, so we're asked to, now you're not seeing the whole picture here. Okay, again, drawing these things by hand is very tedious, and even this is crappy, all right? But I got the 0.04 on some solution, and it looks to me like I would follow along this way, going that way, and follow this way. You know, if I'm following these like arrows, following all these directions, now I'm only getting this part of it. Now it might be a parabola, might be part of a circle, might be part of some other crazy thing, all right? But here's the approximate solution I'm drawing that passes through the 0.04 on my drawing here, which isn't a lot. Now you're actually going to see when I go to the computer that it is actually part of the solution should be a circular shape that passes through the 0.04. So let me pull that up. All right, so websites again. All right. So again, the f prime here, y prime was negative x divided by y. All right, negative x divided by y. Okay, and look at this. You see how all those directions, all those little lineal elements kind of look like they're forming a circular shapes. You know, if you plop down somewhere and followed them, you'd be running around in circles. So I got solution put up. Now let me put in the solution at the point 0,4. So I clicked on that point there. Here's 0,4. And then, all right, now it kind of deforms here. It is a computer. All right, it's not perfect. It should be, well actually, see once it gets down to y equals 0, things get crazy. So you're really getting just the top half of this circle. All right, but it should be a circular shape. But if you're talking about explicit functions, not implicit, you know, something that's actually y is actually a function of x. See how it's the top half of a circle here. Right. Ignore all this zigzaggy stuff, right? You know, once you hit y equals 0, you know, none of this other stuff matters, right? So the solution that matters is that top half circle, right? That semicircle, which again I kind of was starting. Right, if I had some more points in here, maybe I would have seen that it would have come down here and come down here, and but then after that, you know, you don't have a function anymore if you keep going. But yeah, so again, easier to look at, easier, you know, lot less time. You save a lot of time when you put these things up in a computer program. Right? And you might want to play around with some other ones out there. Like I like this slope field plotter through GeoGebra. There's another slope field generator that GeoGebra has as well. And you know, just type in slope field again. Just type in slope field generator. Let me go back again. Slope field generator, and a lot of things come up right away that you can, you know, enter y prime equals, and a slope field or direction field will come up. All right. All right. So hopefully this video helps you when you work on problems, you know, similar to this. And thank you very much for watching.